Quick, graph y equals the sine of x plus 1 by hand, 2 different ways. This is part of the family of functions series. You will need paper and straight edge. We suggest you create grids similar to the ones at the right as needed, and of course press pause as needed anytime during this video. First way is with the sine dance. Recall the graph of one wave of the sine function. Note the 5 key points of interest. These key points and all points are affected by the parameters in the equation. Here the only parameter is plus 1, and this shifts all points up 1 unit. Does not affect any of the x coordinates. So the initial point, which is normally at the origin, a point of inflection, is shifted up 1 to 0, 1. So we'll go ahead and plot 0, 1 as the beginning point. The end of the first period is normally at 2 pi 0. It also is shifted up 1 to 2 pi comma 1. So we'll plot that one. Halfway between the start of a period and the end of the period is another point of inflection, normally at pi 0. But in this case, it is shifted up to pi comma 1. Halfway between this first 2 points of inflection is a maximum at pi over 2, 1. But it's shifted up 1 to pi over 2, 2. And finally, halfway between the second 2 points of inflection is a minimum, normally at 3 pi over 2 comma negative 1, but it's shifted up to 3 pi over 2 comma 0. Pause is needed. Connect to points as a sine wave, concave down, concave up. This is one period of the sine wave. Let's duplicate the wave in the negative direction by going back 2 pi from each of the key points of interest. Go back 2 pi from the max, from the point of inflection, from the min, and connect the points as another sine wave. Concave down, concave up. Draw the line containing the points of inflection. That would be this line here. And what is its equation? Pause is needed to answer that. The equation is y equals 1. You might want to know, where does that 1 come from? And you can see it comes from that parameter right there. Let's compare this to the parent function, y equals the sine of x in blue. And going from blue to green, we shift up each and every single point up 1 unit. We say that the parent function is shifted up 1 unit, or sometimes we say it's translated up 1 unit. Pause is needed. Second way is with a table. Here's our axes values. Complete the table. Pause to do so. Those are the values you should just know. We need to create a second table for the green function. We're going to add 1 to each of the y coordinates only. That is, we're going to keep the x coordinates the same. So let's just go ahead and duplicate those in the table. So adding 1 to each of the y coordinates, because of that plus 1, 0 plus 1 is 1. So the ordered pair we'll plot is 0, 1. 1 plus 1 is 2, so pi over 2 comma 2. 0 plus 1 is 1, pi comma 1. Negative 1 plus 1 is 0, so 3 pi over 2 is 0. And 0 plus 1 is 1, 2 pi comma 1. Connect the points as a sine wave, concave down, concave up. And this is just one period of the wave. Let's plot another one to the left by going back a period from each key point, in this case 2 pi. Each point is backed up 2 pi, one period. And we can connect them as another sine wave. And there again, we compare it to the parent function in blue. Now you try one. Graph y equals the sine of x plus 2. Use either method or both for the practice. Pause is needed. Resume when you're ready to see the answer. And so here's our answer in green here. We compared it to the blue parent function, and every single point is shifted up 2 units from blue to green.